Hello and welcome to Cannon County High School Algebra 2. Today is going to be really fun because we are finally going to put together what we've been learning the last few days. We are going to be doing some probabilities using the normal distribution, and that has to do with standard deviation that we learned about yesterday. So Mr. Lyon, pretty soon you're going to get to take the mask off. Let's see. Let's take a look. We talked about the normal distribution just a little bit yesterday. And we said that in a lot of things in nature, things follow what's called a normal distribution or a bell curve. That's another way to think of normal distribution. There's nothing normal about the word normal here. That's just what it's always been called. But it's like a bell curve. They call it a bell because it kind of looks like a bell. It's tall in the middle and it's short on each side. But a lot of things in nature follow a bell curve or a normal distribution where the mean, whenever you see the X with the little line over it, that means the mean. The mean's in the middle, but most things are in the middle. Some things are way on this extreme, some things are way over here on this extreme. I think we talked yesterday about maybe the height of the people in your class, where some people are really tall, some people are really short, most people are somewhere in the middle, and that's where it is. But yesterday, I alluded to the fact that because we know what standard deviation is, if you have what's called a normal distribution, then there's a certain number of percentages inside plus or minus a certain amount of standard deviations from the mean. And that's what we're going to talk about today. Yesterday, we talked a little bit about this, but we're going to kind of put it more in concrete today. If I were to go one standard deviation to the right of the mean, so that's 1 sigma that way, and go one standard deviation to the left of the mean, so negative sigma in that direction, well then between those two, so if I draw a little line there and a little line there, everything in here from there to there is 68% or 0.68 of the data. So if I said, what's the probability that a random data point is somewhere between one standard deviation of the mean on either side of the mean, that would be, you've got a 68% chance of that happening. If we go another standard deviation, we'll call this 2 sigma and negative 2 sigma in that direction, well, then the probability that any point taken at random on the normal distribution is between 2 standard deviations of the mean. We said this yesterday. That's 95%. You've got a 95% chance, or 0.95, of that happening. And today we're going to talk about what if we go one more? What if we go 3 standard deviations of the mean in that direction, and we've got negative sigma in that direction? Well, from there to there is 0.997. So 99.7% of the data is between 3 standard deviations of the mean. So what we're going to do today is we're going to look at IXL DD.11, DD11, and they're going to ask us just some standard deviations, or ask us to find some probabilities rather, having to do with a normal distribution. And these 3 numbers right here are the key. And remember yesterday I said that the ACT test, when it asks you about standard deviation and normal distributions, there's usually a couple of problems on there. These are the problems they're talking about. They want you to remember these 2 numbers, 0.68 and 0.95. I don't know if they'd ask you for this one or not, but we are going to ask you about it today. So these are the 3 numbers that we're going to keep going back to over and over again. So maybe write these down on a piece of paper. 0.68, 0.95, 0.997. Those are our 3 numbers for the day. Just remember, 0.68 is everything in here. 0.95 is also including these 2, and 0.997 is also including those 2. Okay? So for instance, here's a problem. I don't know if you knew this or not, but a person's IQ is set up so that the average or the mean is 100 and the standard deviation is 10. Did you know that? You've maybe never even taken an IQ test. Maybe you have, but it used to be a really big thing. You don't hear about it quite as much anymore, but most people understand what an IQ is. An IQ of 100 means you're average. An IQ of less than 100 means your intelligence is less than average, and more than 100 is better than average. But the standard deviation is 10. So what's the probability that somebody taken at random in the population has an IQ between 90 and 110? Well, on each of these problems, you're going to see me just sketching a little normal distribution. It doesn't have to be real pretty. But on a normal distribution, we're saying for an IQ, the average is 100. I want you to tell me what's the probability of going between 90 and 110. What is this probability? Well, it says that the standard deviation is 10. So that means we're going 10 in this direction and 10 in this direction. So we're within one standard deviation. When you're within one standard deviation, what's the probability? 0.68. So this would be 0.68. And that's the answer. That's why the ACT loves these problems, because you can get the answer quickly and easily without even needing a calculator, really. Because if you understand the percentages between certain standard deviations of the mean, then you can get the answer really quickly. And that's what they want in the ACT. They want to ask you a lot of questions really quickly. All right, how about this one? What's the probability of getting, or what's the probability that you choose someone at random and their IQ is greater than 130? Well, if the standard deviation is 10, then 130, there's 120, and there's 130. Okay, these very, very few people way over here are the only people that are that smart that have an IQ of over 130. So, let's see, how many standard deviations is that from the mean? 1, 2, 3. That's 3 standard deviations from the mean. So that means that this over here is going to be, well, we know that between, from there to there, right, would be 0.997. But that's also including all these people way over here, and we don't want those people. So what we need to do is we need to figure out what's the probability of all these people in the middle, which is 0.997, subtract it from 1, because 1 would be the entire thing. If we subtract 0.997 from 1, that would give us just this little bit on this end and this little bit on this end. But then what would we have to do? Well, we would have to divide by 2, because we don't want this end. We only want this end. We only want the people with an IQ over 130. So if we were going to figure this out, we would have to first, I'm going to use the calculator for this, we're going to take 1 minus 0.997, and we get 0.003. We would then have to divide that by 2, because we're only talking about one side of the distribution, 0.0015. So the answer would be 0.0015. So if somebody brags to you that they have an IQ of over 130, they're probably not telling you the truth, because only 15 people out of 10,000 have that IQ. So let's try some problems from IXL DD, what was it, DD11. And that's what we're going to do today. We're going to get this one we are going to try to have you get all the way up to 80. And on each one, I'm probably going to be drawing a little picture. It says X is a normally distributed random variable with a mean of 51 and a standard deviation of 5. What's the probability that X is between 36 and 66? Okay, so let's take a look at this. I'm going to just draw a little picture. For every one of these, I'm just going to draw a little picture. This one they're saying the mean is 51, and we want to figure out everything between 36 and 66. Well, it says that the standard deviation is 5. So how many standard deviations to the right are we going? From 51 to 66, that's 15. So if the standard deviation is 5, that means we've gone 3 standard deviations in this direction. And if we go 36, that means 51 minus 15 is 36. So we've gone a negative 3 standard deviations in this direction. So they want the probability 3 standard deviations that way or that way. What did we say that was? Earlier we said that was 0.997. So that's the answer. Again, you should be able to get the answers relatively quickly if you understand what they're asking. Okay, let's jump up a level. right. X is a normally distributed random variable with mean 83 and a standard deviation of 16. What's the probability that X is between 35 and 67? So the mean is 83, standard deviation is 16. We want to figure out that it's between 35 and 67. Okay, so just like before, I'm going to draw myself a little picture so I know what's going on here. It says the mean is 83, the standard deviation is 16, and we want to figure out what is the probability between 35, which is way over here, and 67, which is way over here. Okay, this one's going to be a little bit tougher because it looks like we're going to have to do some subtracting. Let's figure out how many standard deviations away from the mean these are. Well, 83, looks like we're going to have to start subtracting from 83. So let's do 83 minus 16. That's one standard deviation. That would be 67. So we know that this is a negative one standard deviation from the mean. Let's keep going. Let's subtract another 16. That gives you 51. Subtract another 16. That gives you 35. So that means we need to go another 2 standard deviations this way. This is at -3 standard deviations. Okay, so how in the world are we going to figure this one out? Notice we're only on the left side of the mean. So whatever we get for our answer, we're just going to divide it by 2. Well, what is the probability that something is within 3 standard deviations of the mean? Well, that's 0.997. What's the probability that it is within 1 standard deviation of the mean? That's 0.68. So we would have to take 0.997 minus 0.68 to figure out what this is right here. But remember, that would be on both sides, and we're only doing this side. So since this side is the same as this side, what do you have to do with this number? Exactly, you would have to divide it by 2. So that is what we'd have to calculate. We're going to take the probability that it would be inside of 3 standard deviations minus the probability that it would be within 1 standard deviation, and then divide the whole thing by 2 because we're only on one side of the probability. And on the IXL, it says round to the nearest thousandth. So let's see what that comes out to. 0.997 minus 0.68. That comes out to 0.317. We're going to divide that by 2. And we get 0.1585. 0.1585. Now on the IXL, it says it wants to round to the nearest thousandth, so that would be 0.159. So for this problem, I'm going to type in there it is, 0.159. So it really helps to draw a picture on each one. Okay, let's jump up one more level. Let's do one more problem and see how this goes here. We're at 72. Let's see if we jump up another level. Certainly that'll get us 90. Goodness. All right, if we can do a problem up here, then we should be able to do any of them. X is a normally distributed random variable with a mean of 90 and a standard deviation of 25. What's the probability that X is less than 15? All right, let's see. 90, 25, X is less than 15. Let's draw ourselves a picture again. We've got a standard normal distribution. Here's our mean. Our mean is 90. The standard deviation is 25. And we want to find that the probability is less than 15. Well, 15 is way over here. We want to find this probability over here. So before we even do this, whatever this is, remember there's going to be one on both sides. This is going to be another one where whatever we get for our answer, we're going to divide by 2. How many standard deviations from the mean is this? Well, let's start subtracting and figure it out. 90 minus 25, that's 1 standard deviation. We're down to 65. Minus another standard deviation, we're down to 40. Minus another standard deviation, there it is. 3 standard deviations away from the mean is 15, so this is a -3 sigma. Okay, now if we were to go 3 standard deviations from the mean on the right, then we know that between there and there is 0.997, which means how am I going to figure out what's just over on this side? and over on this side, would be 1 minus 0.997, because the whole thing has to add up to 1. And then since we're only over here on this side, we would have to divide all of that by 2. Okay? So the probability that a randomly chosen number here is less than 15 would have to be just this part over here, which is 1 minus 0.997, all divided by 2. So let's do that. 1 minus 0.997 equals 0.003. All right, divide that by 2, and we get 0.0015. That sounds really familiar. That's the same answer we got when we were talking about the IQ problem of someone being over 3 standard deviations on the right. See how it's the same thing on the left as it is on the right? 0.0015. Now, since on the IXL they want us to round to the nearest thousandth, we need to type in 0.002, otherwise it's going to think we got it wrong. So they're asking us to type it into the nearest thousandth. So let's try that. 0.002, and we got it. So there you go. This is a very good lesson because this is something that's going to get you at least an extra point or 2 on the ACT test because these are problems that you can do relatively quickly without a lot of work, and most of the time you don't even need a calculator. So give IXL, which one is this again? DD11. Give IXL DD11 a try. If you have any questions, put them down in the comments, and I will talk to you tomorrow. Thanks for watching. Bye.